19 malicious packages just got caught impersonating Claude Code and OpenClaw on NPM. And before they were taken down, they were silently injecting rogue servers into developers' AI coding tools, harvesting API keys from 9 different LLM providers, and using stolen credentials to spread to even more packages. This is a worm, an actual self-propagating worm, built specifically to exploit the AI coding toolchain. And it landed in the same week that Andrej Karpathy declared an entirely new architectural layer emerging on top of AI agents. One he's genuinely excited about, but also genuinely worried about securing. These two stories are deeply connected, and the implications for anyone building with AI right now are serious. Socket Dev's threat research team, one of the leading supply chain security firms in the NPM ecosystem, published a detailed report on what they're calling sandworm_mode, a Shai-Hulud style supply chain worm spread across at least 19 typo-squatted NPM packages. The name comes directly from sandworm environment variable switches embedded in the malware's runtime control logic. And yes, the Dune references are intentional. Here's how it works. The attacker published packages under 2 NPM aliases, official 334 and java.org, with names designed to catch common typos. Packages like Claude Code, Claude, Support Color, and Yars, that last one targeting the massively popular Yargs library. 3 packages impersonate Claude Code. 1 targets OpenClaw, which recently crossed 210,000 stars on GitHub. Once a developer installs one of these packages, which look completely normal and even maintain their expected functionality, a covert multi-stage payload executes. Stage 1 rapidly harvests .npm-rc files, GitHub tokens, environment variables, and crypto keys. Stage 2 digs deeper into wallets, SQLite databases, and local configs. Data gets exfiltrated through Cloudflare workers, the GitHub API, HTTPS or DNS tunneling as a fallback. But here's where it gets specifically terrifying for anyone using AI coding tools. The worm includes something called the mech.inject module. It deploys a rogue MCP server into the configurations for Claude Code, Claude Desktop, Cursor, VS Code Continue, and Windsurf. That fake server carries embedded prompt injection that tells the AI assistant to silently read SSH keys, AWS credentials, NPM tokens, and environment secrets before every tool call. The model never tells the user. The injection explicitly blocks it from doing so. 9 LLM providers get targeted for API key harvesting. OpenAI, Anthropic, Google, Grok, Together, Fireworks, Replicate, Mistral, and Cohere. And then the worm spreads, using stolen NPM tokens to publish new malicious versions of legitimate packages the compromised developer maintains. It plants CI backdoors by injecting pull request target workflows that serialize and exfiltrate all repository secrets. And it sets a global Git template directory, so that every new repository the developer creates inherits malicious hooks automatically. This attack matters because it is the first major supply chain worm specifically engineered to weaponize AI coding infrastructure. Previous Shai-Hulud variants, version 1 hit in September 2025, version 2 exposed over 33,000 secrets across more than 20,000 repositories. Those were bad. But they targeted traditional developer tooling. Sandworm_mode is different. It understands that developers in 2026 are running AI assistants with deep system access, and it exploits that fact directly. Think about what the MCP injection actually means. The attacker isn't just stealing your keys, they're turning your AI coding assistant into a spy. Every time Claude or Cursor makes a tool call, the injected prompt tells it to first quietly read your most sensitive credentials and send them to the attacker. The model follows the injected instructions because that's what models do. They follow instructions in their context window. This is the concrete, real-world version of the prompt injection risk that security researchers have been warning about for 2 years. And it arrives at a moment when AI-assisted vibe coding means developers are increasingly letting LLMs choose and install dependencies automatically, which means a single typo-squatted package name in a model's response can trigger the entire attack chain without the developer ever manually reviewing the install. The packages have been removed. GitHub took down the infrastructure. Cloudflare pulled the workers. But if any of these packages ran in your environment, Socket recommends treating that machine as fully compromised. Rotate every token, audit every workflow, and check your AI tool configs for unexpected MCP server entries. What to watch for? Socket noted that the malware includes a disabled dead switch that can wipe your home directory if propagation fails, plus a self-rewriting module that uses local Alama instances for polymorphic mutation. These features are currently toggled off, which suggests the threat actor is still iterating. This toolkit is evolving. Expect copycats, and expect every major AI coding tool to face pressure to add MCP server verification and dependency auditing as first-class security features. Now it's worth noting that one of the packages this worm impersonated was OpenClaw, the open-source AI agent framework that has absolutely exploded in popularity over the past few months. And that's not a coincidence. OpenClaw and the ecosystem around it have become so significant that Andrej Karpathy, one of the most respected voices in AI, just declared that an entirely new architectural layer is emerging. He calls it clause. Andrej Karpathy, former head of AI at Tesla, founding member of OpenAI, and the person who coined the term vibe coding, published what's essentially a mini essay on X this past week laying out a framework for understanding what he sees as a genuinely new layer in the AI stack. He calls it clause. The backstory: OpenClaw, created by Austrian developer Peter Steinberger, started as a weekend hack called WhatsApp Relay in November 2025. It was originally named ClaudeBot, got a trademark complaint from Anthropic, renamed to Maltbot, then finally settled on OpenClaw. In about 2 months it went from 0 to over 210,000 GitHub stars. Steinberger was just hired by OpenAI, with Sam Altman personally calling him a genius and confirming OpenClaw will remain open source under a foundation. What OpenClaw does is act as an autonomous AI agent that runs on your own hardware, connects to over 50 integrations: WhatsApp, Telegram, Gmail, Calendar, GitHub, Spotify, browser automation, maintains persistent memory across sessions, can execute shell commands, and most notably, can build new skills for itself through natural language. You tell it what you need, and it writes the code to extend its own capabilities. Karpathy's insight is that OpenClaw and the projects it has spawned represent something architecturally distinct. Quote, "Claws are now a new layer on top of LLM agents, taking the orchestration, scheduling, context, tool calls, and a kind of persistence to a next level." End quote. This isn't just a chatbot. This isn't just an agent. It's a persistent, scheduled, self-extending system that runs continuously on personal hardware. But Karpathy's enthusiasm comes with a sharp caveat. He bought a Mac Mini specifically to tinker with claws over the weekend, noting that the Apple Store told him they're selling like hotcakes and everyone is confused about why. But he said he's, quote, "definitely a bit sus to run OpenClaw specifically. Giving my private data and keys to 400,000 lines of vibe-coded monster that is being actively attacked at scale is not very appealing at all." End quote. He called it a complete Wild West and a security nightmare. Instead, Karpathy pointed to NanoClaw, created by Gavriel Cohen, as a more interesting alternative. NanoClaw's core engine is roughly 4,000 lines of TypeScript. It runs everything in containers by default for security isolation. Karpathy said it fits into both his head and that of AI agents, making it manageable, auditable, and flexible. He also praised NanoClaw's approach to configurability. Instead of config files, everything is done via skills, which aligns with his vision of agents that can build themselves. Karpathy has a track record of naming things at exactly the right moment. He coined vibe coding, and it immediately became the term everyone uses. Simon Willison, the respected developer and AI commentator, noted that Karpathy has, quote, "an ear for fresh terminology," and that claw is becoming a term of art for the entire category. What makes this significant isn't just naming, it's the architectural claim. Karpathy is saying that the real value creation right now isn't happening at the model layer. It's happening at the orchestration layer. The scheduling, the persistence, the context management, the tool integration, that's where the actual product lives. The LLM is an engine, the claw is the car, and the ecosystem is already fragmenting into competing runtimes. NanoClaw in TypeScript, Nanobot in Python, PicoClaw in Go, IronClaw in Rust. Each is taking a different design philosophy: security, reliability, specialization. This is starting to look like the early days of web frameworks, where the underlying protocol was settled but everyone was racing to build the best abstraction on top. The 400,000-line versus 4,000-line debate is the most important architectural conversation happening in AI infrastructure right now. Do you build the maximally capable system and try to secure it later? Or do you build something small enough to audit and reason about? Karpathy clearly favors the latter. And given what the sandworm_mode worm just demonstrated about the attack surface of these systems, that instinct looks increasingly wise. Watch for the Claw runtime wars to intensify. With Steinberger now at OpenAI, the question is whether OpenClaw becomes the officially blessed agent framework, or whether the lightweight alternatives like NanoClaw carve out permanent territory. Also watch for Anthropic's response. Claude Code is both a target for attackers and a potential Claw runtime itself. The company that builds the most secure, most auditable orchestration layer may end up owning a category that didn't exist 6 months ago. Here's the question worth sitting with: the same architectural layer that makes AI agents genuinely useful, persistent, autonomous, deeply integrated into your systems, is exactly the layer that makes them genuinely dangerous when compromised. The race to build claws is also a race to secure them, and right now the attackers are moving faster than the defenders. That's the tension that will define AI infrastructure in 2026. If this is the kind of coverage you find valuable, subscribe. There's a new video here every day. See you in the next one.